right. Hey, starting our seventh unit of the class, we're going to focus on energy, and this one will be a slightly longer unit. We're also going to slip some work and power in along with that energy. All right. Hey, that's the every physics teacher I've ever known. That's their abbreviation for energy. They cut the vowels, and we can sound it out from there. Today we're just going to keep things simple and talk about what is energy. All right. Whoops. Oh boy. Um, First of all, what is energy? So all objects have energy. Um, Energy is not matter, so it doesn't have a mass or volume. It is something else. And energy is the ability to cause change. Okay, it could be change in motion, change in temperature, change in position, any of that stuff. Um, those are all properties of energy, I guess. All energy, regardless of type, is measured in joules. All right, so we're going to use the abbreviation joules with a J on there. And a joule, for those that are super interesting, is equal to 1 kilogram meter squared per second squared. That is a completely useless metric for us. An equivalent to joules. Oh boy, I'm not going to be able to remember this. So it's a form of energy, right? So another form of energy, and one that we most commonly are aware of, are calories. All right, calorie is a measurement of energy, as are joules. I think there's like 4 joules per calorie. I could be wrong on that. I could have that flipped. Don't quote me on that. I should look that up before we start notes here today. But anyway, that is energy. What are the different types of energy? These are all things that we're going to be talking about briefly. The first two are what we're going to be talking about a lot. All right. The first one would be kinetic energy. And so that is the energy of motion. We're all very aware that moving objects have energy to them. We know that getting hit by a moving object, you can feel the transfer of energy from, the dodgeball into your, chest as you're in gym class, or we watch football, we can see the transfer of energy from the linebacker tackling the quarterback, or we can look at things like even like archery. Right, think about that arrow that gets launched, the energy of that thing moving into the object there. So kinetic energy is any kind of energy of motion. The other type that we're going to spend a decent amount of time on is potential energy. So potential energy is energy that depends on the position of an object. Oops, oh no, wrong thing. Um, so what does that mean? So that means the position of an object, it matters here. So elastic potential energy is going to be stored when an object stretches or compresses. So think if I have a rubber band and I pull that rubber band back, okay, that is potential energy based on the position of that elastic band, right? That is if I let go, there's energy involved. Same thing with the spring. I have a spring and I pull down on that spring, there's going to be energy stored and involved there. Two, chemical potential energy. That is energy stored in chemical bonds. If you took biology class, you probably talked about ATP. ATP is full of chemical potential energy of just waiting for that third phosphate to get snipped off and release that little pocket of energy. And then the one that we're going to spend our time on is gravitational potential energy. That is energy stored due to position above the ground. So if I take my coffee mug and I have it up above my head, I know the higher that I raise that, the more potential energy that is I'm building up in that object. Okay, that's positioned in there. Now remember, it's not like free energy. Like I had to, in order to create that elastic potential energy, I had to pull that rubber band back. So I had to put energy into the system to create gravitational potential energy. I had to use my muscles and raise that object up. So there's not free energy there. These last five we're going to spend less time talking about. That is thermal energy, which is energy in the form of heat. Electric energy, which is energy and moving electrons. Nuclear energy is going to be energy stored in the nucleus of the atom. Sound energy is interesting. It's energy that travels as waves. They need matter to travel through, though, but we've all heard of ultrasounds before. And then radiant light energy. So energy that travels as waves and it doesn't need matter. So light energies in that way Think about UV light has a lot of energy that can do harmful things to your skin. So we're going to spend our time talking about kinetic energy and potential energy. And really our first unit is lesson, we're going to be talking about how those two go hand in hand, right? So as I raise the coffee mug above my head and let it go, that gravitational potential energy is going to be converted to kinetic energy until it hits the bottom, when it's 100% kinetic energy as it hits the bottom of the ground there. Okay, so your first assignment is going to be just some real basic graphing, so some pie charts in there. Check it out. I have my answer keys attached, so you'll be able to kind of look at what I'm kind of looking for there, but just kind of an introduction to kinetic and potential energy.